Okay, in this video, I'm going to go through the 2.2, 2.3, 2.4 review. So the first questions, you have to provide the graph. So these are our parent functions that we had talked about previously. So once you know these parent functions, you should be able to sketch them for yourself. So this is your cubic function. And so since you have these arrowheads going both directions, your domain and your range will both be the same. So you will be able to use all numbers, but you're going to write it in interval notation like this. The domain and range are the same. As opposed to this next one, this is your square root function. And so you've got to know that this looks like this. You start here and you go forever and ever that way. So your domain is going to start at 0 and it's going to go to infinity. And your range, your lowest value is also 0 and it also goes to infinity. Okay, so they're the same for domain and range for each of these, but they're different from one another. So hopefully that is clear. Okay, so now here's a piecewise function. All you have to do is identify the domain. So I'm going to do my little flashlight. And so what I want to do is figure out if I'm doing domain, this is the furthest left I can do from my x. So I know that I'm going to start at negative infinity. So now once I hop on, I can move to the right on the x. I get down here and I appear to be stuck. But remember, this x value of 1, I can also go up this way, hop on this piece, stuck again, same x value I can drop down, and I can continue this way. So I am, in effect, able to go from negative infinity to positive infinity. Let's talk about the range. Okay, so range. This is the lowest value I can start. And so that lowest value is a 0, and I can equal it. So start out by having a bracket with a 0. Now, what should I do? My goal is to get as high up on the y as I can. So if I go this way, I'm going to run into problems here. So let's go this way. So I hop on at 0, and do you see how I can go forever and ever? So picking that root, I can go to infinity. Okay, done. And remember, infinity always has the parens. Okay, here's another one down here. It's already a piecewise function. So let's look at this. Here's where I'm going to hop on from my domain. I can go all the way to the left, so that's negative infinity. And then I get to here, but this is the same x value, and then I can turn the corner and go on forever and ever. So my domain is negative infinity to positive infinity. My range, I'm going to start down here, and if I go up this side, I can go forever and ever. So that's going to start at negative 3. So this is going to be, and it can equal negative 3. Start at negative 3, that's the lowest y value I have, and I'm going to go all the way to infinity, done. Okay. Average rate of change. I'm going to ask you this 3 different ways, but every time I ask it, you're going to think to yourself, oh, she's just asking for slope. This is slope of the secant line drawn to these functions. Okay, so slope is just change in y over change in x, or y1 minus y2 over x1 minus x2. That's all that is every single time. So I want you to remember that so that you're not caught off guard saying, I wonder what that could be. It's not rocket science. It's just finding the slope. Okay, you've got to be comfortable using absolute value functions. And you have your calculator you can use, but we probably should be able to do this by hand. So here are your x values. So there's your x1 and your x2. You need to figure out what the y's are. So I want to evaluate the function where x is -8. Okay, so I'm going to plug in a -8. So that's 2 times -8 minus 2 plus 2. Okay, do the work in between the absolute value symbols. That's -8 minus 2 gives me -10 plus 2. Okay, take the absolute value. That -10 becomes 10. That's multiplied, and then 2 is added to it, so that's 22. So right now I have 1 point, and that is -8, 22. Now let's get the other one. So you're going to say, let me evaluate it at x is -3. So this is going to be 2 times, and then wherever I have the x, I'm going to put a -3 minus 2 plus 2. Once again, do the math inside the absolute value. That gives you -5. Take the absolute value of -5 and you get a 5. That's multiplication, and then add 2 to it. That is equal to 12. So my other point is going to be -3, 12. Now you have your x and your y's. So your average rate of change is going to be, I'm going to start out with, I guess I don't know, it doesn't really matter. It doesn't matter. That's the main point. So I'm going to say 22 minus 12 over, go back up to the 8, -8. -8 minus a -3. So that's going to be 10 over a -8 plus 3. That's a -5. So that average rate of change is going to be -2. And that is our answer. Okay, the average rate of change for this problem was -2. Okay, so that's getting average rate of change when I give you the function. Same problem down here. I give you the function, I give you the x's, you have to figure out the y's. So this is each of your x's, okay? So what I'm going to do is I'm going to say, all right, let's evaluate this at 5. So 3 times radical. 5 plus 4 is 9 minus 2. Okay, radical 9 is 3. That's being multiplied, and then you subtract 2 away. So 9 minus 2 equals 7. Okay, so that's our first point. So what was it? 5, 7. Get your second point. F of 12. Now I made this 12. On some of your copies it was 11. So make it 12 because it's going to make your life easier. So if this is going to be 12 plus 4 and then minus 2, that's 3 times radical 16 minus 2. Radical 16 is 4. 3 times 4 is 12 minus 2 equals 10. So my next point is 12, 10. Okay, those are my 2 points. Average rate of change, what is it? It is just the slope. So average rate of change, it's going to be a change in y over change in x. I'm just going to start 7 minus 10 over 5 minus 12. So that's a -3 over what? A -7. So if they're both negative, that's a positive 3/7, and that is my answer for the average rate of change for this problem. Okay, still asking you average rate of change. Now I give you a table. So you're going to look at this table, and we're going to figure out the average rate of change. They want the average rate of change between these 2 points. So in green, my x is 0, and my x is 10. They gave me the y's already. My job is just to say change in y over change in x. So I'm going to say 10. So my, I'm going to have my x's down here, my y's up above. If I start out with the 10, I'm going to say 2 minus 6 over 10 minus 0. So that's a -4 over 10. If If you want to reduce it, it's -2/5, and that is the average rate of change according to this table. Okay, now we're going to change our color, and I'm going to grab 5 and 15. So x is 5, 15. Here are my y's. Do the exact same thing. Change in y for change in x equals, grab the y's first, -12 minus 0, go back to the 5, 5 minus 15. This is -12. This is -10. 12 over 10 is what it is. And you can reduce that. This is positive over positive. So it's negative over negative is positive. And that if you want to reduce it to 6/5, you are golden. Okay, so we used a table to figure out average rate of change. Third way I can give it to you. I'm going to give you a graph, and I'm going to say I want to figure out the average rate of change between these 2 points. So figure out the points. Here's 1. That's going to be 2, 0. Here's the 6. That's going to be 6, 3. Okay, again, not rocket science. Change in y, but change in x. Grab your y's first. 3 minus 0, then grab the x's. 6 minus 2, 3 over 4. And that's my average rate of change. Okay, so when you have a graph like this, maybe it's helpful for you if you sketch in the line. Okay, that is your tangent line. Excuse me, that's your secant line. You're finding the slope of that. That slope is what I just found. Okay, and my answer was 3/4. So be comfortable getting average rate of change either from a formula, so that's the function formula, from a table, or from a graph. Okay, the graph allows you to write in the secant line, and that's what you're finding the slope of. So you may find that the easiest to understand. Okay, that brings us to our favorite thing, piecewise function. So I'm going to use lots of color for this. So follow along. Okay, I have 4 pieces to this function. It is one function. So therefore, the interaction between the pieces has to not violate the vertical line test. Okay, I'm going to do the evaluate last. So we're going to do the pieces. Now, number one thing, when you grab the first piece and they tell you this is your domain restriction, and it says x has to be less than -6, you must use -6. Tell yourself it's open. It's an open circle. I know you can't equal -6, but you can equal very close to it. Therefore, we have to absolutely start there. Okay, that's the only open piece. Then go one more digit less, okay? And I would tell you to get your line going. This is a one-sided restriction. So therefore, the other restriction is going to continue without bounds. So that means you're going to have an arrowhead on your function for there. Okay, let's plug in the -6 into this x. That's -6 plus 1 gives me a -5 for my y value. Then plug in the -7 right here. -7 plus 1 gives me a -6. Okay, we're going to go ahead and we're going to graph that. So here's the coordinate pair. -6, -5. Oh, I'm going to tell you right now, you have to go by 2's for the y. 2, 4, 6, 8, 10, 12. Because if you look at it in totality, you're not going to be able to get your y's on here unless you go by 2's. So I'm going by 2's. The x's will fit fine. And you would see that if I had graphed everything on the table, which I have not. So these will be fine as 1's. Okay, so this is fine as 1's. Whatever you do on one side of the x, you've got to do the exact same thing on the other side of the x. Same as the y. Whoops, that's -5. And this is -6. Okay, -7. All right, let's plot that point. So we're going to look at there and we're going to say, all right, I've got -6, comma, -5. Go over -6, down -5, which is right here with an open circle. Okay, then go to -7 and -6, which is right here, and that is going to continue. Okay, so I can put that out there like that. Okay, so we have those 2 points. All right, so now let's continue graphing. Okay, now we're going to do the second piece. So for the second piece, I'm going to use green. And so if you're given a sandwich like this, a couple of things. You're going to use those numbers exactly. Okay, so I'm going to say -6, -5, -4, -3. Because -6 says x has to be greater than or equal to that, this is closed, only at -6. Then x is less than -3, that makes this open. Okay, when you have a sandwich, you're never going to have arrowheads attached. That is being sandwiched or stopped. It starts and it ends. So there's no extension like I have in the first piece. Okay, so now to get your y values, you're going to take your -6, plug it in where the x is. That's going to give me -6 minus 2, which is -8. Absolute value of -8 is 8, and 8 plus 1 is 9. Okay, -5 minus 2 is a -7. Absolute value of -7 is 7, and 7 plus 1 is 8. Okay, -4 minus 2 is a -6. Absolute value of -6 is going to be 6, and 6 plus 1 gives me 7. And we've got one more. -3 minus 2 is a -5. Absolute value of -5 is 5. 5 plus 1 is 6. Okay, so we're going to graph this now. So come on down, and let's see what we have. -6 and +9. Okay, so -6 and +9 is up here, right in the middle, and it's closed, so it's going to be filled in. Okay, that makes sense because right below it is an open circle, so I know I'm okay. Then -5 and 8. Okay, -4 and 7. And then I get down to -3 and 6, and that is going to be open. So I'm going to connect only the green. Okay, do not connect the green with the blue. All right, so that's the next piece of it. Okay, so now let's go for the third piece. So again, I have a sandwich. Okay, I'm going to pick those numbers that they are giving me. -3, -2, -1, 0, 1. At -3, I say I have an equality, so that's going to say be closed, just like it was above. At +1, I have a strict inequality, so that's going to be open. Okay, take your -3 and plug it in your piece of your function. -3 minus 1 is -4. -4 times -4 is +16. Minus 10 is 6. -2 minus 1 is -3. -3 times -3 is 9. And 9 minus 10 is a -1. Okay, -1 minus 1 is a -2. And -2 times -2 is 4. 4 minus 10 is a -6. 0 minus 1 is a -1. -1 times -1 is 1. 1 minus 10 is a -9. 1 minus 1 is 0, so therefore this is just a -10. And now we're going to plot the red. So come down here. The first one is -3, 6. So look what's going to happen. I am going to fill in the open circle with the red. Okay, then I have -2 and -1. So that's going to be about here, right? And then I have -1 and -6. That's here. 0 and -9. that's going to be here. And 1 and negative 10, that's going to be an open circle that's right here. So then connect just the red. Okay, there you have it. Okay, we need one more color. So let's go with brown. And the last one is going to be in effect when x is greater than or equal to 1. So again, I'm going to pick the 1, and I'm going to go 2, and I'm going to give myself a line because I can keep going. This is going to be closed right here. And then look what happens here. No matter what my x is, this is always going to be 4. So let's go ahead and do that. So I have 1, 4, and that means it's going to be right here, and it's going to be closed. So that's closed. And then I'm going to do 1, 2, and this is going to go like this. Okay, so I have all my pieces graphed. Let's use our table to see if I can do the evaluate. Okay, have I ever plugged in an x value of negative 7? Yep, right here. So that's going to be a negative 6. What about a negative 5? Yep, my x value of negative 5 is right here. That makes that an 8. What about negative 1? Yep, right over here. That makes that a negative 6. What about 0? Yep, right over here. That makes that a negative 9. And what about 5? Well, I didn't plug in a 5, but I would plug it in here or here. And no matter what I plugged in, I would get a 4 back. So I've now done the evaluate. Last thing to do is the domain and range. So let me turn on the little flashlight, and I'm going to start my x's way down here. So that's going to be negative infinity. Okay, so let's see where I can go. I get to here, and I can go up here to this x value. I can come down, and then I can continue to slide. And now this is the same x value as this, and then that can go all the way to the right. So my domain's going to be negative infinity all the way to infinity, done. The range is going to be something different. So let's look at the range. Where can I start? Well, because of this arrowhead, I can start all the way down here. I get to here, and I say, okay, I can go across here on the same y value. I can then go up on y values, and I have to stop here at 9. So my range is going to be from negative infinity up to 9 inclusive. Okay, there's no arrowhead on that green section, so therefore I have to stop at the edge, and the edge is at negative 9. All right, here's another one to do. Oh, I should have said one thing. Did I fix these already? Yes, I did. Okay, remember we had to fix these things to make sure that they lined up and everything matches. So I fixed it on here already. Okay, another piecewise function. I have how many pieces this time? Another 4 pieces. So let's go ahead and we will analyze this. Okay, so my first piece is going to be where x is less than negative 4. So I'm going to do that in blue. Where do I start? You best be saying negative 4. And then you have to be less than that. So go to negative 5. This is one-sided. There you go. It has to be less than it. So this is going to be open. Okay, we're going to do the whole table, and then I'll come back and plot. Okay, so then if I plug in a negative 4, 2 minus 2 times negative 4. So that's 2 minus a negative 8. So that's adding then. So that's 2 plus 8. So that's going to be 10. Plug in a 5. So if this becomes a negative 5, that's going to be 2 times a negative 5, which is a negative 10. So it's going to be adding. So it's going to be 2 plus 10. So that's going to be a 12. Okay, so we're going to keep going. Let's plot this one. What numbers will I use? All of these. Negative 2, negative 1, 0, and 1. This is closed because it says x is going to be less than or equal to negative 2. And the last one is going to be open. Notice I'm only marking the first one and the last one. Okay, plug in a negative 2. Negative 2 minus 1 is negative 3. Absolute value of negative 3 is 3. 3 plus 2 is 5. Negative 1 minus 1 is a negative 2. Absolute value of negative 2 is 2. 2 plus 2 is 4. 0 minus 1 is a negative 1. Absolute value of negative 1 is 1. 1 plus 2 is 3. And last one, 1 minus 1 is 0. Absolute value of 0 is 0. And 0 plus 2 is 2. Okay, we're going to keep going. I'm going to go gray. Okay, what numbers do we pick? I picked the sandwich. Notice there's no arrowhead on my sandwich. So I'm going to pick 1, 2, 3, and 4. This one is closed. This one is open. Plugging in a 1. 1 minus 1 is 0. That's going to be a 2. 2 minus 1 is 1. 1 squared is 1. 1 plus 2 is 3. 3 minus 1 is 2. 2 squared is 4. 4 plus 2 is 6. 4 minus 1 is 3. 3 squared is 9. And 9 plus 2 is 11. Okay, last little piece. Here we go. Okay, what numbers am I going to pick? I'm going to definitely start with 4 and then go to 5. Okay, and this is one-sided, so I'm going to go forever and ever. X has to be greater than or equal, so that means that's going to be closed. Go ahead and plug in your 4. 4 times 3 is 12, plus 2 more is 14. 5 times 3 is 15, plus 2 more is 17. Okay, what I'm noticing now is that my y's are going to go beyond this grid if I count by ones. So I'm going to count by twos for the y. 2, 4, 6, 8, 10, 12, 14, and negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. I'm going to still go by ones for the x-axis. Okay, so we're all set. Okay, do we want to do the evaluation first? Let's look here. Okay, if I have negative 5, that's going to go in the blue. All right, so let's see if I have it already done, and I do. That's going to be a 12. Okay, negative 3. X has to be less than negative 4 and then greater than negative 2. There is nothing I can do here, so I'm going to say NA. Okay, negative 1. That's going to be in the second one in the red. So this will be in the red. Let's see if we have one figured out already. And we do, and it's 4. Okay, look at 1. Now this is a dangerous one because I can't use the second piece of it. I can't use the red because that's less than 1. So I'm going to have to use the gray. So come down here, go to the gray. It's closed there. That's going to be a 2. Okay, I can only use the gray. I cannot use the red. Okay, G is 5. That's going to work out for this green because this says X has to be greater than 4. So did I use it already? I did. Here's the green, and it's 17. So I've got all those values. You will only have one value for each at the most. So we didn't have any values for G is negative 3, but that's okay. But you'll never have more than one. If you have more than one, you've got to rethink it because that means that this is not a function, and I'm telling you, it's a piecewise function. Okay, time to graph. I'm going to do the blue piece first. I have negative 4, and then I have a positive 10. So negative 4, positive 10, and that's open, so that goes right here. and negative 5, positive 12, and that's closed because anything else is closed once you get past the first one, and that goes forever and ever. Okay, so that looks pretty good. Now, hold on a second. I think I'm going to have to go by threes. So, why don't I just do that now? So I'm going to erase. I'm going to make these go up by threes because I don't think I'm going to get up to 17 otherwise. So let's go by threes. So I should have said that in class. My apologies. So this is 3, 6, 9, 12, 15. Yeah, that'll work. 18, and 21. Okay, the x's are still fine. Negative 3, negative 6, negative 9, negative 12. And do I have any of those negative big ones? No, I don't, so I'm okay. Okay, so I could continue, but I don't need to. Okay, let's go back to the blue. It is negative 410. So negative 410 is going to be somewhere here, and I want that to be an open circle, right? And then 12, negative 5, 12, negative 5, 12 will be here. That one's open. This one's closed. And I'm going this way. Okay, so let me make sure that that looks like it's open. So let me do that again. So I said that was negative 410, negative 410 right here, open. There we go. Okay. Now let's do the red. So I have negative 2 comma 5, and that's closed. So negative 2, and then I have 5. Yep. So negative 2, 5 is about here, and it's closed. Okay. And then I have a negative 1, 4, negative 1, 4 about here. Remember, everything else is closed until I get to the end. 0, 3, that's right here. And then the last one is 1, 2, that's open. So this is 1, 2, and that is open. Okay, so that should look something. Now, what shape is this? This is absolute value, so it should be pretty much a straight line, right? So that's that one. Okay, next one is going to be a parabola. That's the gray. Okay, I have 1, 2, and so that matches what I had before, so that means I'm going to fill in this. So I filled in the red with the gray. Okay, so then I'm going to go 1, 2, 2, 3. 2 and 3 is right here, and then 3 and 6 is right here. Now look, this is a parabola. And then 4 and 11, but that has to be open. So you see how you have the shape of a parabola? It's a curve, not a straight line. Okay, ready for the last one? That's going to be in green. So I have 4, 14. So this is 4. 14 is going to be right below here, and that's closed. So I can fill that circle in right there. And then 5, 17, which is roughly here. This is a straight line. So we are going that way. Oops, let me do that again. Going that way. Okay, so now we have everything. So we have to do domain and range. So let's think about this. Out here is where negative infinity is for my x. So I'm going to go here. Now look what's going to happen. I can't move any place. So I'm going to have to stop. I'm going to have 2 sections. At least 2 sections. So that's going to go from negative infinity up to, what's my x value? Negative 4. Then I'm going to, and can I equal negative 4? No, it's an open circle. Then I'm going to unite that 2. Where do I start again? I'm going to start over here. That's a negative 2, and I can equal that. Then I'm going to hop here. Here, this x value is the same as that x value, so I can go forever and ever. Okay, so I'm going to start here at negative 2, and I'm allowed to equal it. Negative 2 to infinity. Okay, so you have two segments. Okay, then come down here, range. Here's your lowest value right there. Once I'm on the lowest, what can I do? Oh, look what I can do. I can come up this way, and then I can come across, and then go forever and ever. So that means my lowest value is here, which is a y of 2. So that's going to start at 2 and then go to infinity. Okay, so that's done. Okie doke. Now we're going to analyze some functions. All right, so I have 2 functions to analyze, and then I have n behavior, and then we are done. Okay, so let's analyze this. So where is the function increasing? So I'm going to talk calculus for a second. The function's increasing where a tangent line drawn to the function has a positive slope. Okay? When the tangent line drawn to the function has a slope of 0, it is neither increasing nor decreasing. Then you see how this has a negative slope, so it's decreasing. So that's how I want you to think about it, and then you won't get things incorrect. So where is it increasing? Okay, you're reading x's. So you can start at that -8. It's a point, so I'm going to have it be a box or a bracket. Okay, so it's going to increase up to -6, but look, at -6, you're neither increasing nor decreasing. Then what happens again? Down here, I have a slope of 0. So that's where things are going to start, but I can't really equal it, so I put a paren. So -2 up to here, because these all have positive slopes, right? So it has to be increasing. So when I get to 3, positive 3, I stop again. Then I'm going to decrease, decrease. Oh, look at that. It's a 0 slope. That is at 5. So I'm going to start again near 5 and then go forever and ever because these are all positive. Okay, so that's where the function's increasing. So where is it going to be decreasing? Well, it's going to decrease from, look at this, -6 to -2, -6 to -2, and then where else? It looks like 3 to 5. 3 to 5. So I can use my other answer to get my answers, or I can go back to the graph. Either way is fine. Okay, next thing. What are the zeros? The zeros are where it crosses the x-axis. So these green dots are my zeros. So I have a 0 at -4, comma. I made that 0.8, comma, 5, comma, and 9. Okay, these zeros are going to help me figure out where the function is greater than 0, where it's greater than or equal to 0. So let's first do where is it greater than 0. So it's greater than 0 from -8 to -4, not inclusive. Then it's greater than 0 from 0.8 to 5, and then it's greater than 0 from 9 to infinity. Okay, when you do the greater than or equal to 0, you get to include your roots now. This one was a bracket. Everything else is going to become a bracket, because now you're allowed to equal, now you're allowed to equal 0. Okay, you don't ever make infinity brackets, so now we're good. Okay, so now let's do where is it less than 0? That's below. So it's going to be below from -4 all the way to 0.8, which ends up being this and this. And then it's also below from 5 to 9. 5 to 9. Now, here I have less than or equal to 0. You can now change every single paren into a bracket. Isn't that beautiful? Okay, because you can equal the 0, so you can include those roots. Okay, local maxima. Okay, for local maxima, you are going to look as you go from left to right where all those vertices are. Okay, so those are little maxes. So it's going to be a local maxima. These are coordinate pairs. So it's -6, comma 6, and then 3, comma 3. They're both local. What are the local minima? Okay, local minima are going to be here and here. Those are the local. Okay, so what are those coordinates? -2, comma -5, and 7, comma -2.2 is what I said. Okay, is there an absolute max? No, because look, this keeps going. So there's no absolute max. Is there an absolute min? Yes, because I only have an arrow going one way. So that's going to be my absolute min. And where was that? My y is -5. So that was at -2, comma -5. So this is a yes. The other one was a no. Okay, these are coordinate pairs. That's why I have parentheses. Okay, so that's that analysis. Now let's do another one. Okay, for this one, I have 2 arrowheads. So how does that impact things? So where is this function increasing? So I read it from left to right. I am increasing where I have positive slopes. I am increasing, increasing, and increasing, increasing. So let's see where that is. Go to your vertices. So that's -6 all the way to the -4 with parens. And then I have 1 to 5. And then I have 7 to infinity. Okay, where is it decreasing? So that's going to be -4 to 1. And then 5 to 7. Oh, and I forgot the other one here. Let me just move this over. Hold on. Let me get this, and we're just going to move that a little bit. Good. And then I'm going to go from, it's decreasing from -infinity up to the first point, which is at -6. And that's also united with it. Okay, so those are all the areas where it's decreasing. Okay, what are the zeros? So zeros look like a -2 and a 3. Where is the function greater than 0? So from -infinity up to -2, and then again from 3 to infinity. Okay, greater than or equal to it. How does that change my answer? Whoops, that was not good. Okay, that makes this a box, and that makes this a box because now the function is allowed to equal 0. Okay, where is it less than 0? Okay, so less than 0 is going to be just right in here. So that is from -2 to 3. Less than or equal, change those parens to brackets. Okay, let me just get rid of this. Okay, how about local maximum? Okay, here's a max. Here's a max. Here's a max. So I've got 2 of them. So write them down. I have -4, comma 7. Again, it's an XY, so it's just a coordinate pair. Both parens. What's that? The local minimum. Okay, here's a local min. Here's a local min. Here's a local min. So we have 3 of them. -6, comma 5. -1, comma -3. And 7, comma 1. So again, they're just coordinate pairs. You're not going to unite them. They're just standalone. Is there an absolute max? Because I have these arrowheads heading up, I am going to say no. Is there an absolute min? Yes, there is. Where is it? Well, it's where the y value has the lowest value, and that lowest value is right here at -1, -3. Done. Okay, so we've got those two done. Now let's do some easy, quick ones. Okay, end behavior. Look for the arrowheads. This arrowhead says, as x approaches -infinity, y will approach positive infinity. Okay, this end behavior says, as x approaches positive infinity, y is also going to approach positive infinity. Okay, now this one has an asymptote. So look what's going to happen. I still have two end behaviors because the end behavior occurs where the arrowheads are. So this is going to be, as x approaches -infinity, what's happening to y? Y is going to approach 0. It can't get above that x-axis. So y is approaching 0. So make sure you understand that. This one is more traditional. As x approaches positive infinity, okay, because you're reading off of this axis, x's are getting bigger and bigger. What's going to happen to y? Y is going to approach -infinity because you're reading off of here, and those values are getting lower and lower. Okay? And that's it. So if you know this material, you are good to go. So go back, hit the stop button when you want to listen to this, and make sure that you could explain it to me or to somebody else. Okay? I hope this helped.